Allahu Akbar, Allahu Akbar, Allahu Akbar, Allahu Akbar. أشهد أن لا إله إلا الله.
Assalamu alaikum. My name is Abdul Rahman. Welcome to my YouTube channel Islamic and GK vlog. Now we are going to talk to you about moon, Earth's sole natural satellite and nearest large celestial body known since prehistoric times. It is the brightest object in the sky after the sun. It is designated by the symbol. Its name in English, like that of Earth, is of Germanic and Old English derivation. The moon's desolate beauty has been a source of fascination and curiosity throughout history and has inspired a rich cultural and symbolic tradition. In past civilizations, the moon was regarded as a deity. Its dominion dramatically manifested in its rhythmic control over the tides and the cycle of female fertility. Ancient lore and legend tell of the power of the moon to instill spells with magic, to transform humans into beasts, and to send people's behaviors swaying perilously between sanity and lunacy. Poets and composers were invoking the moon's romantic charms and its darker side, and writers of fiction were conducting their readers on speculative lunar journeys long before Apollo astronauts in orbit above the moon sent back photographs of the reality that human eyes were witnessing for the first time. Centuries of observation and scientific investigation have been centered on the nature and origin of the moon. Early studies of the moon's motion and position allowed the prediction of dates and led to the development of calendars. The moon was the first new world on which humans set foot. The information brought back from those expeditions, together with that collected by automated spacecraft and remote sensing observations, has led to a knowledge of the moon that surpasses that of any other cosmic body except Earth itself. Although many questions remain about its composition, structure and history, it has become clear that the moon holds keys to understanding the origin of Earth and the solar system. Moreover, given its nearness to Earth, its rich potential as a source of materials and energy, and its qualifications as a laboratory for planetary science and a place to learn how to live and work in space for extended times, the moon remains a prime location for humankind's first settlements beyond Earth orbit. The moon is a spherical rocky body, probably with a small metallic core, revolving around Earth in a slightly eccentric orbit at a mean distance of about 384,000 km. Its equatorial radius is 1,738 km, and its shape is slightly flattened in such a way that its bulges a little in the direction of Earth. Its mass distribution is not uniform. The center of mass is displaced about 2 km toward Earth relative to the center of the lunar sphere, and it also has surface mass concentrations called mascons for short that cause the moon's gravitational field to increase over local areas. The moon has no global magnetic field like that of Earth, but some of its surface rocks have remanent magnetism, which indicates one or more periods of magnetic activity in the past. The moon presently has very slight seismic activity and little heat flow from the interior, indications that most internal activity ceased long ago. Scientists now believe that more than 4 billion years ago the moon was subject to violent heating, probably from its formation, which resulted in its differentiations or chemical separation into a less dense crust and a more dense underlying mantle. This was followed hundreds of millions of years later by a second episode of heating, this time from internal radioactivity, which resulted in volcanic outpourings of lava. The moon's mean density is 3.34 grams per cubic centimeter, close to that of Earth's mantle. Because of the moon's small size and mass, its surface gravity is only about one-sixth of the planet's. It retains so little atmosphere that the molecules of any gases present on the surface move without collision. In the absence of an atmospheric shield to protect the surface from bombardment, countless bodies ranging in size from asteroids to tiny particles have struck and graded the moon. This has formed a debris layer or regolith consisting of rock fragments of all sizes down to the finest dust. In the ancient past and largest impacts that made great basins, some of which were later partly filled by the enormous lava flows. These great dark plains called Maria are clearly visible to the naked eye from Earth. The dark Maria and the lighter highlands, whose unchanging patterns many people recognize as the man in the moon, constitute the two main kinds of lunar territory. The Mascans are regions where particularly dense lavas rose up from the mantle and floated into basins. Lunar mountains, located mostly along the rims of ancient basins, are tall but not steep or sharp peaked because all lunar landforms have been eroded by the unending rain of impacts. In addition to its nearness to Earth, the moon is relatively massive compared with the planet. The radio of their masses is much larger than those of other natural satellites to the planets that they orbit. The moon and Earth consequently exert a strong gravitational influence on Earth, other forming a system having distinct properties and behaviors of its own. Although the moon is commonly described as orbiting Earth, it is more accurate to say that the two bodies orbit each other about a common center of mass called the barycenter. This point lies inside Earth about 4,700 km from its center. Also, more accurately, it is the barycenter rather than the center of Earth that follows an elliptical path around the Sun in accord with Kepler's laws of planetary motion. The orbital geometry of the Moon, Earth, and the Sun gives rise to the Moon's bases and to the phenomena of lunar and solar eclipses. The Moon displays 8 bases: new waxing crescent, first quarter, waxing gibbous, full waning gibbous, last quarter, and waning crescent. New moon occurs when the moon is between Earth and the Sun, and thus the side of the moon that is in shadow faces Earth. Full moon occurs when the moon is on the opposite side of Earth from the Sun, and thus the side of the moon that is illuminated faces Earth. First and last quarter, in which half the moon appears illuminated, occur when the moon is at a night angle with respect to the Sun. When viewed from Earth, the waxing and waning crescent bases occur when about one-fourth of the moon is illuminated, and the waxing and waning gibbous bases occur when about three-fourths of the moon is illuminated. Earth as seen from the moon shows the same bases in opposite order. From the perspective of a person on Earth, a solar eclipse happens when the moon comes between the Sun and Earth, and a lunar eclipse happens when the moon moves into the shadow of Earth caused by the Sun. Solar eclipses occur at new moon, and lunar eclipses occur at full moon. Eclipses do not occur every month because the plane of the moon's orbit is inclined to that of Earth's orbit around the Sun by about 5 degrees. Therefore, at most new and full moons, Earth, the Sun, and the moon are not in a straight line. The distance between the moon and the Earth varies rather widely because of the combined gravity of Earth, the Sun, and the planets. For example, in the last 3 decades of the 20th century, the moon's apogee, the furthest distance that it travels from Earth in a revolution, ranged between about 404,000 and thousands 404,000 and 406,700 km, while its perigee, the closest that it comes to Earth, ranged between about 356,000 and 500 and 370,000 and 400 km. Tidal interactions, the cyclic deformations in each body caused by the gravitational attraction of the other, have braked the moon's spin such that it now rotates at the same rate as it revolves around Earth, and thus always keeps the same side facing the planet, as discovered by the Italian-born French astronomer Gian Domenico Cassini in 1692. The moon's spin axis precesses with respect to its orbital plan. Its orientation changes slowly over time, tracing out a circular path. For the empirical rules that Cassini formulated about the moon's motion, in accord with Kepler's second law, the eccentricity of the moon's orbit results in its traveling faster in that part of its orbit nearer Earth and slower in the part further away. Combined with the moon's constant spin rate, these changes in speed give rise to an apparent oscillation or libration, which over time allows an observer on Earth to see more than half of the lunar surface. In addition to this apparent turning motion, the moon actually does rock slightly to and fro in both longitude and latitude, and the observer's vantage point moves with the Earth's rotation. As a result of all these motions, more than 59% of the lunar surface can be seen at one time or another from Earth. The orbital eccentricity also affects solar eclipses, in which the moon passes between the sun and Earth, casting a moving shadow across Earth's sunlit surface. If a solar eclipse occurs when the moon is near perigee, observers along the path of the moon's dark inner shadow see a total eclipse. If the moon is nearer apogee, it does not quite cover the sun. The resulting eclipse is annular, and observers can see a thin ring of the solar disk around the moon's silhouette. The moon and Earth presently orbit the barycenter in 27.322 days. The sidereal month or sidereal revolution period of the moon, because the whole system is moving around the sun once per year, the angle of illumination changes about 1 degree per day, so that the time from one full moon to the next is 29.531 days. The synodic month or synodic revolution period of the moon. As a result, the moon's terminator, the dividing line between day side and night side, moves once around the moon in the synodic period, exposing most locations to alternating periods of sunlight and darkness, each nearly 15 Earth days long. The sidereal and synodic periods are slowly changing with times because of tidal interactions. Although tidal friction is slowing Earth's rotation, conservation of momentum dictates that the angular momentum of the Earth-Moon system remain constant. Consequently, the Moon is slowly receding from Earth, with the result that both the day and the month are getting longer, extending this relationship back into the past. Both periods must have been significantly shorter hundreds of millions of years ago. A hypothesis confirmed from measurements of the daily and tide-related growth rings of fossil corals. Because the moon's spin axis is almost perpendicular to the plane of the ecliptic, the plane of Earth's orbit around the sun, inclined only 11 and 2 degree from the vertical. The moon has no seasons. Sunlight is always nearly horizontal at the lunar poles, which results in permanently cold and dark environments at the bottoms of deep craters. The study of the moon's motions has been central to the growth of knowledge not only about the moon itself but also about fundamentals of celestial mechanics and physics as the stars appear to move westward because of Earth's daily rotation and its annual motion about the sun. So the moon slowly moves eastward, rising later each day and passing through its bases new first quarter, full last quarter, and new again each month. The long-running Chinese, Chaldean, and Mayan calendars were attempts to reconcile these repetitive but incommensurate movements from the time of the Babylonian astrologers and the Greek astronomers up to the present. Investigators looked for small departures from the motions predicted. The English physicist Isaac Newton used lunar observations in developing his theory of gravitation in the late 17th century, and he was able to show some effects of solar gravity in perturbing the moon's motion. By the 18th and 19th century, the mathematical study of lunar movements, both orbital and rotational, was advancing, driven in part by the need for precise tables of the predicted positions of celestial bodies for navigation. While theory developed with improved observations, many small and bustling discrepancies continued to appear. It gradually became evident that some arise from irregularities in Earth's rotation rate, other from minor tidal effects on Earth and the Moon. Space exploration brought a need for greatly increased accuracy, and at the same time, the availability of fast computers and new observational tools provided the means for attaining it. Analytic treatments, mathematical modeling of the moon's motions with a series of times representing the gravitational influence of Earth, the Sun, and the planets gave way to methods based on direct numerical integration of equations of motion for the moon. Both methods required significant input based on observation, but use of the latter led to great increase in the accuracy of predictions. At the same time, optical and radio observations vastly improved. Retroreflectors placed on the lunar surface by Apollo astronauts allowed laser ranging of the moon from Earth, and new techniques of radio astronomy, including very long baseline interferometry, permitted observations of celestial radio sources as the moon occulted them. These observations, having precisions on the order of centimeters, have enabled scientists to measure changes in the moon's speed caused by terrestrial tidal momentum exchange, have advanced understanding of the theories of relativity, and are leading to improved geophysical knowledge of both the moon and Earth. Though the moon is surrounded by a vacuum higher than is usually created in laboratories on Earth, its atmosphere is extensive and of high scientific interest. During the 2-week daytime period, atoms and molecules are ejected by a variety of processes from the lunar surface, ionized by the solar wind, and then driven by electromagnetic effects as a collisionless plasma. The position of the moon in its orbit determines the behavior of the atmosphere for part of each month. When the moon is on the sunward side of Earth, atmospheric gases collide with the undisturbed solar wind. In other parts of the orbit, they move into and out of the elongated tail of Earth's magnetosphere, an enormous region of space where the planet's magnetic field dominates the behavior of electrically charged particles. In addition, the low temperatures on the moon's night side and in permanently shaded polar craters provide cold traps for concentrable gases. Instruments placed on the lunar surface by Apollo astronauts measured various properties of the moon's atmosphere, but analysis of the data was difficult because the atmosphere's extreme thinness made contamination from Apollo originated gases a significant factor. The main gases naturally present are neon, hydrogen, helium and argon. The argon is mostly radiogenic. It is released from lunar rocks by the decay of radioactive potassium. Lunar night temperatures are low enough for the argon to condense, but not the neon, hydrogen or helium, which originate in the solar wind and remain in the atmosphere as gases unless implanted in soil particles. In addition to the near surface gases and the extensive sodium potassium cloud detected around the moon, a small amount of dust circulates within a few meters of the lunar surface. This is believed to be suspended electrostatically. Assalamu alaikum. Thanks for watching.